Hello and welcome everyone to this PV Tech Talk webinar, our first in 2021. My name is Mark Osborne, Senior News Editor at PV Tech, and I'll be your moderator today. PV Tech has teamed with Qcells and TÜV Rheinland in this 45-minute webinar and 15-minute Q&A session to highlight the need to raise the bar in PV module quality and reliability by introducing a new quality control system. This is for silicon-based PV module manufacturing and is designed to be fit for the future needs of the industry. Our presenters will be Christian Talbitz, technical expert in the R&D and technology department at Qcells, and Lukas Jakic, business field manager for PV modules and solar thermal at TÜV Rheinland. We will also have Daniel Felsch-Cruz, Head of Global QM, Customer Management and Final Goods at Qcells, accompanying us in the Q&A session. As per usual, we will have staff from Qcells able to answer any questions during the webinar, and please start asking your questions anytime now. Okay, that's it for me, but we'll pass the floor over to Christian to begin the presentation. Thanks, Christian. The floor is yours.
Thank you, Mark, and hello to my presentation about the quality controlled PV program, in short Qcpv, from TÜV Rheinland. In the next slides, I will talk about why and how Qcells adapted the requirements of this program. Lukas Jakic from TÜV Rheinland will join me, providing inside information about the Qcpv program and its development. But first, I want to start with some basics about standard IEC certification. Here I want to answer some basic questions like, what is a certification? What is a standard IEC certification able to do? And what is a standard IEC certification not able to do? This slide here now is about what is a certification. On the left-hand side, you can see what a certification process basically looks like. At first, a test module gets characterization measurements, then it is tested according to a standard, and finally, there is again a characterization measurement to determine if the module passed or failed the certification. This process is done or supervised by an independent third party. In the PV industry, the certification process is typically done according to IEC certifications, especially in Europe. In the middle of this slide, you can see that IEC standards consist of recommendations and regulations given by the so-called International Electrotechnical Commission. For PV, the most relevant IEC standards are the IEC 61215, which has a focus on the performance of the module, and the IEC 61730, which has a focus on the safety of a PV module. If all tests and requirements of these standards are fulfilled, a module gets a certificate and an IEC mark shown on the right-hand side. Now we come to the question, what is this kind of IEC certification able to do? At first, such a certification can align. One example is shown here on the left-hand side with the performance measurement. The IEC defines how the performance of a module shall be measured and specified. This way, it is possible to easily look up and compare module power. A standard IEC certification can also protect, which is illustrated in the middle of the slide. Basic protections, like for example against mechanical stress or hotspots, are required to pass the certification process. This way, catastrophic failures, like shown in the pictures below, shall be avoided. Overall, a standard IEC certification can guarantee a basic suitability. As illustrated on the right-hand side, it can guarantee performance and durability of the modules during the first year or years. But module performance and product warranties typically cover 10 to 25 or even more years. With this, we come to the question, what is a standard IEC certification not able to do? As shown on the left-hand side, while it can guarantee first-year suitability, standard IEC certification cannot verify long-term reliability. In addition, as illustrated in the middle of the slide, it cannot test regarding special failure modes like PID and LETID. Also, solder and backsheet durability are not focus of standard IEC certification, but these are essential for module reliability. In today's PV industry, a lot is happening regarding module sizes and design. It is therefore more important than ever to assure a sufficient durability of all components and designs used. Finally, a standard IC certification cannot assess module of mass production. Like shown here on the right-hand side, typically an IC certification is done with a few prototypes. After pass of IC certification, years of mass production of this module type with IC mark is possible without verification of quality and durability. So it is impossible to detect issues in production or decrease of material quality. Now I want to hand over the floor to Lukas from TÜV Rheinland, who will talk about TÜV Rheinland's view of the situation and a possible solution.
Yeah, Christian, thank you very much for your first slides, and thanks, Mark, for the introduction. I'm happy to present my slides within this presentation to the new quality control PV service of TÜV Rheinland. First, a short overview what the service provider TÜV Rheinland is doing. It's for more than 35 years. We are acting in PV with a lot of inspection experience and quite a lot of locations and lab areas we have available. So the most important thing is the worldwide, the global network of PV experts we are working with. So the new service quality control PV is written in a 2PFG standard of TÜV Rheinland. So in this case, we first had a look at the market needs to see whether the standard is important, which focus it shall has. So therefore, we see that the manufacturers wish to differentiate their products. And of course, investors and insurers wish to evaluate their investments. So that's very important, but very, very in focus is the pace in the new technology changes that need to be addressed by an appropriate quality control system. Furthermore, the testing scheme needs to assess long-term reliability. So therefore, what is TÜV Rheinland going to do within this new service? The focus is on ensuring quality surpasses standard, the type approvals and verification of manufacturers' regular quality and surveillance measures at the production sites. Furthermore, the material and supplier monitoring programs need to be controlled. So within that, we have some targets and benefits of this program in risk migration and higher quality, especially to have a regular monitoring of the production site. So within that, we see Qcpv as one of the most progressive programs in the market to continuously monitor on product quality and durability in mass production. So we have the known failure systematics in PV. So if you have a look at this graph from the left side, the blue block usually reflects the failures in the early years of an installation of PV modules. And this is usually what type approval and certifications, safety certifications identifies. But what we want to go through is within the graph to the right-hand side, where we have a focus on the middle term and end of lifetime failures. So these are the failure rates we want to reduce, and this is where we want to find some higher confidence in reliability of the PV modules and to have a higher quality stability in relation to the lifetime of a PV module. Several factors of influence are introducing in this slide. So we have usually UV light on the left-hand side, UV light that influences the quality of polymers and gives a quality assurance feedback. Also, on the right-hand top, wind and humidity are usually influencing the module reliability, the electrical stability, and mostly also the mechanical strength of the PV modules. Furthermore, environmental influence like temperature and snow loads are influencing modules' quality. A further very important factor is on the left side down, the production influence. So here we need to have our focus from the production view for surveillance monitoring, the quality assurance, and the controlled suppliers for the production. So all these factors are bundled in the new quality control PV program. I hand over back to Christian with the next slide.
Thank you, Lucas. Due to the reasons listed from Lucas, we at Qcells wanted to implement an additional test and surveillance program and decided on the quality controlled PV program from TÜV Rheinland. With TÜV Rheinland, we found a partner with whom we could not only rely on his great experience regarding module testing, but we also had the unique opportunity to bring in our own experience as one of the world's most experienced cell and module manufacturer. The result is a Qcpv program which is now starting with the G9 PV module series from Qcells. The Qcpv basically consists of three parts illustrated on this slide. The first one is shown on the left-hand side. It is the initial qualification part. If new designs or materials shall be used, they have to pass realistic and harsh tests, which durations are up to 3 times higher compared to standard IC. Here we already follow the draft of the new reliability standard ICTS 63209, which will be finalized in the next years. Also, the resistance of the product against recent failure modes observed in the industry is tested in this part. The second part of Qcpv, illustrated in the middle of this slide, is about monitoring of mass production. The TÜV representative on site randomly selects modules from every production site, which are then tested in monitoring tests. Finally, on the right-hand side, the third part of the Qcpv is shown. Here, beside a comprehensive supplier audit program, the material footprints, or the characteristics of the material, of core materials used in production, is determined and monthly monitored. Especially the monthly monitoring of modules and materials from mass production conducted and or supervised by TÜV representatives on site is, as far as we know, unique in the industry. This has numerous advantages for the PV industry as well as for the customer, which is emphasized on this slide, on the bottom of this slide. The first part of the Qcpv, shown again on the left side, verifies long-term reliability so that it can be assured much better that the module warranty will be met. The second part, illustrated in the middle of the slide, actually monitors the mass-produced modules, confirming that not only the initial prototype modules, but also the mass-produced products is of high quality. Finally, the third part, again shown on the right-hand side, monitors important core material and their suppliers, which guarantees continuous high quality of the used material. This way, unexpected issues in the field operation can be avoided. Now again, I want to hand over the floor to Lucas from TÜV Rheinland for more detailed insights into Qcpv.
Thank you, Christian. So once again, a slide with 3 parts of the standard. Part 1, extended stress testing for the qualification, which in detail defines the module type, and if any kind of change in design on the qualified module type needs to be re-qualified, then there is a retesting guideline also mentioned in the TÜV PFG. So part 1 gives us a view or a high confidence in reliability and long lifetime cycle. Part 2, regular surveillance monitoring. monthly quality testing, during production testing, and the continuously monitoring of the mass production gives high confidence in quality stability. Part 3, the view on the supplier materials and the listing of critical core and core suppliers and materials, and a review of the supplier evaluation and audits of the manufacturer efforts will lead to control suppliers and reliability of material properties. All that will finally, if passed, be confirmed by an issue of certification. So let's go a little bit in detail about the testing sequences of the part 1, the extended stress testing that is orientated on the extended stress testing of photovoltaic modules for risk analysis. So the ICTS 63209. Here within that standard and also within the TÜV PFG, it is allowed to provide more samples per sequence, per test, to increase also confidence in test results. So let's have a look on the testing tree. From the left side, sequence 1A and 1B has its focus with high level testing on UV front, UV back side for polymer materials. So these test sequences have in focus to improve the stability of polymers. Sequence 2 and 3 are mostly environmental testings that reflects the well-known damp heat test and the thermal cycling test, but this is much beyond the IC standard. So for everyone who is maybe used to it, but usual IC is 1000 hours. Here we have twice with 2000 hours and of damp heat, and usual is 200 cycles within IC type approval, and here we have 600 cycles of thermal cycles. Then one row to the right hand side, sequence 4, 5, and 5 are characteristics, so with leaded detection and PID detection sequences, we have a look on degradation risk of the PV modules. A further sequence on the right hand side of the testing tree is sequence 6. It is mostly a mechanical stress test, a sequence with a static mechanical load test and a dynamic mechanical load test following the IC 62782 with 1000 pascals for 1000 times cycles. So followed by TC50 and humidity freeze. One special point is that after the damp heat test, we have a proposed final stabilization of the modules, means we are following the edition 2 of the IC 61215 with the here well-known or the mentioned stabilization method. So that is the testing tree for part 1 for qualification of the design or even the module type to be qualified. Part 2, the regular part of the standard is that every month, every production site of a manufacturer shall provide 6 modules for this testing tree. That is, again, a very critical testing tree if you have a view on sequence A and B with environmental testing much beyond the standard and with PID detection after continuity test of equipotential bonding. And on sequence D, every month a humidity freeze with a EL imaging optionally, but then focusing on the retention of junction box. We usually within IC use 40 Newton only. Here we have applied the force from the US side, the 156 Newton, which is much more reflecting the reality as a force on mounting surfaces. So this is first pillar of part 2 of the standard, the monthly monitoring testing program. And additionally, we have the during production testing within part 2, means the manufacturer performs on this testing tree on several samples per day, per line, or even per week. The wet leakage test, a reverse current test, a GL content test, continuity of equipotential bonding, and a bypass diode functionality test. So these are tests which will lead to a mass of results that need to be reviewed and controlled by a third party TÜV Rheinland staff, and which leads to high quality stability in a mass production. The third part of the 2 PFG is regarding the supplier and materials of a production site. So the manufacturer in a first point has to generate a master list of suppliers, which within a risk assessment. Therefore, the manufacturer defines core materials, and these core materials shall be focused on polymeric footprint in the second point, where the materials income needs to implement an identification or an analysis measure, for example, a GCMS or a DSC method, or even an easy microsection analysis can lead to a polymeric footprint if supplier or if purchased material from a supplier could be identified as those material that was purchased. So here we have defined within the standard 1 test sample from a minimum of 2 suppliers per month need to be analyzed. A further point of part 3 is regular supplier audit. Means a minimum of 1 supplier per year for 1 core material defined above need to be audited by the manufacturer, and this audit will be monitored by TÜV Rheinland third party. So I guess this criteria is a low criteria. Manufacturers with quite a high level of quality will regularly, much more regularly, perform supplier audits within their quality control systems. I hand over to Christian again.
Thank you, Lucas. Yes, now I also want to go a little bit more into detail regarding how the Qcpv is implemented at Qcells. On this slide, the first Qcpv part, the initial qualification, is illustrated. As already shown from Lucas, if new designs or materials shall be used in production, the numerous tests shown on this slide have to be conducted and passed. I know there are a lot of information on this slide, but don't be afraid, I will not go too much into detail. As you can see on the upper side, harsh climatic stress in damp heat at high temperature and humidity, as well as during big temperature variations in thermal cycling, are part of this, with durations which are 2 or 3 times higher than done in standard IC certifications. As mentioned before, also PID as well as LETID are tested, as shown on the right side, and again the conditions are harsher than required in current PID or LETID standards or drafts. Finally, the module compound durability and the backsheet durability is tested by special sequences shown in the middle of this slide. These involve mechanical and climatic stress, as well as stress coming from UV light irradiation. In addition, the Qcpv is designed as a learning program. This means that in the future, this program can be dynamically updated according to the observations and requirements in the industry. Here, I also want to mention that we at Qcells do not stop here. we continue to test our products further internally and are continuously developing new test sequences and methods. Now, finally, of course, I also want to show how the Qpix Duo G9 module series performed in the Qcpv qualification tests. But first, what is the G9? On this slide, a short product overview is given. Again, I will not go too much into detail. The G9 is basically a next step evolution on our former module types, in that it boosts all the excellent features found in earlier modules. It consequently develops the quantum cell as well as quantum duo module technology shown on the left and in the middle to achieve even higher power, but with a high reliability because most of the technologies in it are already well known and successfully tested and implemented in the past. Higher power is realized by the new so-called zero gap technology shown on the right side. It removes basically the gap between the cells in the string, so the cells are packed more closely together, which increases module efficiency. Now back to the Qcpv testing. Here are the results, and as you can see, due to Qcel's high internal quality demands, the G9 shows an outstanding performance. All tests are not only pass, but the power loss is even much lower than required in typical ISC standards, which are the 5% power degradation, marked here with a dotted line. Now we come to the monitoring parts of the Qcpv program. On this slide, the monthly monitoring tests of the module production are illustrated, which Qcel's implemented to meet the requirements of the Qcpv program Part 2. Every month, modules from production are tested in damp heat at high temperatures and humidity, as well as in humidity freeze and thermal cycling at high thermal variations, which up to 2 times the duration of a typical ISC certification. The modules are randomly selected by an independent TÜV Rheinland representative on site, which I will now explain a little bit more in detail. On the slide, the monthly monitoring procedure is illustrated in more detail. First, the TÜV Rheinland representative is randomly selecting modules from every production site. These modules are sent to a certified so-called module test line, in short MTL, from Qcel's. We call it line and not test center or laboratory because these facilities are testing much more frequently, much more modules in much more automatized processes than typically done in laboratories. In other words, these are lines producing certification, quality, and reliability test results. Then in the next step, the TÜV representative on-site randomly assigns each module to one of the monitoring tests. Finally, the tests are performed at the MTL. A standardized test report is created and the TÜV Rheinland checks and confirms the results. Now we finally come to the part 3 of the Qcpv program, the monitoring of suppliers and materials. Qcel's identified together with the TÜV Rheinland core materials of the PV module production. From these materials, the characteristics, we also call material footprint, is determined with sophisticated test methods. After that, this material footprint is monthly monitored to ensure the same material quality for production. Also included in the third part of the Qcpv program are stricter supplier material specifications based on risk classification of the materials, our previous experience with the supplier, and a special focus on core materials. On this slide, I want to give you a little bit more insights into how we implemented the part 3 of the Qcpv program. Here the monitoring procedure for the backsheet material is illustrated in more detail. First, the production site prepares monthly material samples from the current production lot and sends them to Thalheim, Germany for testing in the laboratory on site. This time I mean laboratory, because beside the module test line in Thalheim, we also have a well-equipped laboratory for more advanced analysis. In the next step, the laboratory in Thalheim uses the differential scanning calorimetry, DSC method, for determining and monitoring the material characteristics, so the footprint of the material. Finally, the results are uploaded in a material footprint database and shared with the production site. Now I will again hand over the floor to Lukas for final information about the Qcpv from TÜV Rheinland.
Thank you, Christian. So, if all these three parts are passed by the manufacturer and monitored and, according to the headline, controlled by TÜV Rheinland third party, then the quality controlled PV certification can be recommended. Besides that, a CDF, a construction data form, is necessary, as all the design properties of a module will be listed in the CDF. Besides that, all monitoring, review of test protocols and assessment need to be satisfied. As a minimum criteria, the IEC 61730 as a safety qualification needs to be covered, as this is also reflecting a minimum yearly factory inspection. So we could have the case of failure in this program, and by this the manufacturer needs to generate a failure analysis and a corrective action plan to TÜV Rheinland. And then he can start a repetition of test sequences with a minimum of 2 samples. So within that, usually a 30 days timeline is given for a corrective action plan. So for the confirmation of acceptance, TÜV Rheinland issues to Qcells already a test mark and a keyword. So this is shown here, and each module type here in this example, the Qcpv Black ML G9 Plus type, can be traced back on the Certipedia webpage of TÜV Rheinland. And if you touch the keyword node, you get a keyword node that explains in detail on certipedia.com what the program quality control PV and its 3 parts is about. So again, we have a first mover, Hanwha Qcells, issued certification from November of 2020. So short summary from my side about the quality control PV program. We have generated here a program that is for the PV module manufacturer high-level USP on their quality control system. The high manufacturer's efforts in implementing Qcpv leads to increased confidence in reliability and risk minimization of their PV modules. So as mostly driven by the market to differentiate their products and to evaluate the investments for investors, this test specification was developed based on the extended stress testing for PV modules, ICTS 63209, which is under development or under consideration still. And by this, we are focusing for reliability testing beyond the IC standards, the typical type approval and safety standards. So within the program 2PFG 2715 for quality control PV, this program can, according to the market requirements and to the module technology, can be revised regularly. Quality stability is crucially given by regular surveillance monitoring of the mass production in this program. For sure, we have to perform all parts, and this can be traced back per module type and design. As you can see in the last point, quality control PV is already recognized in the market. You see an example of CEC within Australia, where they list in their application form already the Qcpv standard, besides other TÜV Rheinland standards, for example, for the leaded detection to PFG 2689. I give over again to Christian and thank everyone for your attendance.
Thank you, Lucas. Yes, with this, I also want to conclude my presentation. I talked about standard IC certification and that it is able to align methods and guarantee basic suitability. But I also showed that it cannot assess long-term reliability and the actual quality of mass production. And therefore, as Lucas already said, we needed some additional test methods or the test program. This is really what the market, what we at Qcells saw that it is needed. When I talked about the quality control PV program from TÜV Rheinland, I explained that Qcells found this program to be most extensive and stringent, involving independent and random on-site testing of running mass production. In addition, regular analysis of monitoring of the material characteristics, we call it footprint, is included in the Qcpv program. And it is also designed as a learning program which can be dynamically updated according to the requirements of the industry. And due to this numerous advantages, Qcells decided to be the first mover in the Qcpv program, and we had the unique opportunity to also bring in our own experience. The QPeak Duo G9, shown here on the right side, is the first product passing the Qcpv, and I could show that it passed with outstanding results due to the Qcells' high internal quality demands. Yes, Qcells will continue to test and monitor modules and materials according to the Qcpv and also beyond that. Yeah, with this, I end my presentation and thank you for your attention. I will pass now back to Mark for the Q&A session.
Well, thank you very much there, Christian and Lucas. Thank you. Really, really detailed and looking at a lot of the questions coming in. I'm glad we've actually got a fair bit of time to hopefully go through these. Once again, everybody that's on the webinar today, if you do have questions, please put them in if you want them answered. We also have Qcells staff here that have been trying to help you. But obviously, when we do finish the Q&A session, the actual platform will remain open for a short period of time. So if there are any more questions or your question hasn't been answered, don't worry. If you stay on, we can get to them. There's normally typically a little bit of a flurry of questions while we're trying to sort out a lot of these questions that have already come in. And I guess lots of things here, but maybe it's really good to start with sort of a common theme here. People are just trying to comprehend, how this all came about. And I think maybe partly from my own sake, this was one of my questions that I felt people would need to know about. But perhaps Christian or Daniel, how did really questions looking at, how did Qcells manage to become the first mover in this program? Because people are, I guess the second question to follow up, and I think Lucas could answer this as well, is, this isn't something specifically designed for Qcells. It's just your involvement in this as the first customer. But I wanted to get your views on that because there's various questions that have been asked that relate to this. Okay,
Mark, thanks for that question. Yeah, so in this case, we have for the first partner, Hanwha Qcells, for this program. We are very lucky, as Hanwha Qcells also has been a part of the development of that, as well as we founded a committee of industry partners where we received feedback to the developed program of quality controlled PV. And so for sure, the hands on the 2 PFG standard are with TÜV Rheinland, and we will decide whether something in the standards we are following or orientating at, or the cell, or not only the cell, the module technology, the pace of it will change, require any changes. And for sure, we have the chance, as it is a 2 PFG standard of TÜV Rheinland, we have the chance to update on this standard by a revision and to adjust requirements on it. Yeah.
Okay, and I guess from the Qcell side, again, sort of partly mixed in with this is, you know, that this is truly independent from your perspective. That this is, you know, how do you take this on board? Because people are just trying to think whether this is a collaboration that's unique, but it's actually just what's your own take on how you're working with TÜV Rheinland on this? Because I'm assuming you're giving an example of what other people can expect when they join the program.
Yeah, when I can answer from my perspective as an R&D employee from Qcells, we already had a lot of experience regarding reliability testing. We tested far beyond the ISC standard internally, but then when the TÜV Rheinland contacted us and was talking about his new program, we were very interested, because it was also for us the most stringent program at that time, and we wanted to improve our quality and show this that we improve it, and that we have improved it already internally, and that we can pass this test very good. And therefore we were very interested. And then it was even an additional benefit that the TÜV Rheinland was also open to our experience and our ideas, and this was for us very, very positive.
Okay, cool.
Yeah. Sorry to interrupt. And also some additional information about what Christian has said is, as he said, we did this internal testing, and we were looking for a partner where we can show also to the customers, to have a transparency that the tests we are doing are not just internally, but also to give a confident results to our customers. And therefore, TÜV Rheinland was a great partner, and they offered us that program, and actually that was what we were looking for, and so we joined that program.
Yeah, great, Daniel, because actually that leads into there's quite a few questions, but on the specifically, you know, in more detail, this one, I guess for both of you in the sense, but Lucas perhaps. We've got a question here, was noting that why did you introduce such a harsh thermal testing environment regime in the program? And I guess that kind of leads on from what you said, Daniel.
Okay. So the test sequence itself, and the definition of the test sequence and the test specifics are mostly orientated and following the ICTS 63209 part 1 for modules, so the extended stress testing for PV modules. And this is still under development. That's why I informed Forma that a revision of the standard is aimed, as I expect that this extended stress testing standard is not in the final version, and we orientate on this group who is developing such test sequences that are near to reality. Near to reality, of course, in the testing world, with factors that give a harsher test specimen than usually occur in reality. So if we talk about temperature rising from -40 to +85 degrees, for sure this will not on any place of the world occur, but quite a wide range of temperature occurs in several regions. Therefore, we have to test and reflect more long reliability test sequences in it. So the test specimen in detail have not developed by TÜV. So we are following working group, especially on the extended stress testing standard.
Okay. There's been quite a lot of, back to you again, I'm sorry for Lucas, but a lot of points raised about the TÜV's sort of monthly inspections. And obviously this is a key differentiator here. This is, you know, actual factory inspections. So I'm not surprised that there's a lot of questions related to this, but perhaps answer this particular question, but broaden that out a little bit about some of the monthly aspects. I think there was some, well, I'll come back to that one in a minute, but will the TÜV monthly inspections be planned or short notice inspections? And this is really to, I guess, ensure that it's standard production modules rather than, you know, specially prepared modules for inspection.
Yeah. So in one of my slides, I explained that we will be not send out monthly an inspector to each production site to pick out randomly from the production running the samples for the monthly quality assurance program. So what we will do is we define a sample rate, so with a factor of 10, to the modules samples number we need to have for the monitoring program, the monthly one. So means we get a list of serial numbers from the actual or from current running production, and we pick out those 6 samples of that. So this has not to be done on site, so this can be done remotely or maybe an on-site inspector that is on the lab side of customers, for example. Also, this is possible. So the randomly sampling is made by a definition of sampling and does not need to have an inspector or an auditor on site. So if you imagine a manufacturer with plenty of manufacturing sites, production sites, to realize a monthly visit all over the globe might be too much effort. So we have all the high effort in this program, and the most focus on the monthly quality program is on part 2 of this standard, is that a high effort of testing on a regular basis taken out from a mass production. This is the focus on that we get in results and a database where we see a regular quality stability is given, and this can be read from the monthly monitoring program as well as from the during production testing program that is part 2 in this standard.
Okay. Thank you, Lucas. One for Qcells. I'm just going to put 2 of these together. Obviously, Qcells has started the certification with the G9. Will it also be sort of retrospectively backdated to other modules? And I think as well, just throw in the question about you know, there's a lot of R&D spending going on at Qcells at Thalheim. Is this partly in respect to actually getting to this second degree, this higher level of actual quality control and certification and inspection, because you need to do a lot more than just the simple lab testing work. So perhaps we could get both you and Christian and Daniel to answer that.
Yes, from as an R&D perspective, yes, partly this investment is used for increase of for this program, for the Qcpv. For instance, I know that we needed some additional climate chambers, and we also, for example, want to introduce also additional laboratory tests for the part 3, for the investigation of our core materials. So these are part of these investments will also go into these. But of course, we also look for the future. We want to develop new technology and new efficiency modules and cells. And for these, of course, we also need the investments.
Yeah, and also in addition to that, as of now, it's not planned to have a retrospective certification of older module types, because we started right now with a G9, which is the latest generation we offer, but also thinking about next generations, of course, to run through that program. This, for us, as quality head, is always the intention to offer a product to the market that survives for the long time warranties, and therefore it's again in our interest itself to have an extended testing rather than just following the IEC standards, which is based from technology point of view maybe sufficient, but not for all the markets we deliver our modules worldwide. So therefore we have to find a common test sequences that we can use to again ensure the quality of the modules. And therefore this extended testing is really mandatory based on what we've seen, based on the markets, market feedback we can get everywhere in the official chats and official sites. You can see that. And therefore, yeah, again, our intention is here to have this testing done.
Right. There's been a couple of questions related to backsheet material. I'm not surprised. One, let me put these together for you, Lucas. One is asking, is there a rating system, particularly as it relates to earlier failures in backsheet material? And secondly, if there is a backsheet material issue that is identified, how long would, say, Qcells have to address that? What time span would they have to address those kind of material issues? Because obviously this is part of the real world of doing this kind of stuff from a production perspective.
Yeah. Okay, thank you for that question. For sure, polymeric materials are in focus of this part 1 qualification testing, and this might be explained additionally, and maybe it was not clear enough in the presentation. Each new design and change of backsheets or silicon or junction box materials need to undergo a retesting plan of this qualification test plan part 1. So for sure, as you mentioned, there is a focus, especially with the sequence 1A and 1B, on with a high irradiance of UV on, and in the combination with environmental testings on the backsheets, as market shows quite a lot of problems in the power plants. And for sure, the experience TÜV Rheinland has in its lab with the extended stress testing of polymers, we are insisting on having these long-term UV test sequences within, and see whether the polymeric materials are oldering and beginning to older, or even give a fixed failure on the PV module safety, and show us a view on the reliability of the product.
Okay.
There's no rating, which is an outcome between different polymer backsheets, backsheet suppliers, as an outcome of the program. That's not, no.
Yeah. No, really good. Thank you. Yeah, I understood. This one for perhaps Daniel. How long did it actually take to gain certification? And I think that's someone obviously asking because, how long is a piece of string sometimes? You have to go through it all and actually pass the certification. But perhaps from your perspective, how long did it take?
Actually, we started with this kind of certification issue already in 2019. So it took us almost 1 year to gain that certification at the end. And yeah, it took some time, I do understand. But if you look at the test sequences and so on, some long-lasting tests. So it would take some time to achieve the certification at the end. Good point.
Mark,
yes.
Maybe I can add to this timeline of Qcpv also my knowledge. So as Daniel explained, according to the test sequence times, it is possible to gain certification within 4.5 months if you pass all through and stay strict on the program. So means if you go through the qualification testing plan of part 1, you have in the first run focus on a time of testing for 4.5 months. That's in fact yes.
Right. Okay. There was I'd stay with you for a moment, Lucas. There was a question raised early in the webinar, which I thought was really interesting. Is I think it was your slide 9, where you look at the failure rates have a high failure rate, mellows out in the middle range years, and then you're looking at the long-term failure or pass rates for modules, that have gone on to 20 years. So the question really was trying to understand, why is the failure rate so high at the beginning? I think you may have answered part of that question.
Yeah, okay. So as I mentioned, the blue block or the blue box of type approval and safety standard usually identifies the early lifetime failures. And early lifetime failures are usually identified by the minimum criteria to get your PV modules in the markets. So constantly we are speaking about the IC 61215 and IC 67030, and which usually identifies any material incompatibilities or even production processes that lead to early lifetime failures. So not the focus on long term. So the graph shows at the beginning early lifetime failures which have their origin in these two reasons: material incompatibility and production processing.
Got it. Okay. Here's looking at the time, we've probably got a chance to add one or two. There's so many questions here, but again, I find this one interesting. I think we tried to address it, both Christian and Lucas in their presentations, but I think it's worth coming back to this. What is the motivation for module manufacturers to pursue stricter quality testing? And I guess there was a subset of that is, are you seeing demand for more reliable PV systems, and who's requesting that, or where is this coming from? Perhaps Christian, or Daniel, maybe jump in on that.
From my perspective, this comes from both sides. So it comes from external, so from the customer. Customer is demanding higher quality, and also from inside, from fuel cells, we also saw the need to have a high quality because the climate change in the world, the climate is becoming harsher and harsher, and we deliver our modules to all climates in the world, and there are a lot of harsh climates out there. And this is the reason, because we want to give the customer highest quality, and therefore we saw the need of a very good quality program internally, and also wanted to show this transparently to the customer. And this Qcpv program is best program to show this.
Just to support Christian's argumentation here is, as I mentioned before, we see from time to time the market data, and the market data shows that even having a IC certification shows that it is not sufficient. We still see many issues in the market, and therefore a need for a higher quality or a more sufficient testing is really needed. And again, therefore we use this Qcpv program.
Would you? Yes, Lucas, sorry.
I might add to Daniel directly in one line that if the type approval and safety qualification, this is a one-time certification. Yes, we have a yearly inspection, and this is for market access. But what the need from market, even from manufacturer side, as well as from EPC and insurance side, investment side, are if there is a program and a certification scheme much beyond the standard, that's the most requested point, much beyond in cases of regular control, so continuously monitoring of the product quality and if the durability in mass production is given. And this is usually what a certification scheme under IC does not reflect, and Qcpv gives good insight and gives a great USP to the manufacturer, that he can show my production side, my mass production, my regular quality stability is given by the program quality control.
Okay. Look, we've just gone slightly over, but and there's quite a few questions that came through that we simply didn't have time. I'm sorry to all the great questions that came in, but I know that QCells and TÜV are happy to follow up, and I know the staff have been very busy getting contact details so that they can follow up with some really excellent questions. And I want to thank once again Christian, Lucas and Daniel for joining us on this really revealing and I think just showing a pathway towards just greater quality and performance that the industry is demanding. The industry will need, especially when we are seeing such rapid advancements in cell and cell-to-cell interconnect technologies, and especially we didn't get a chance to talk specifically about bifacial modules, but there was the odd question on that. And I think the industry is moving at a faster pace, and this type of testing via the production plants themselves, I think is really the way forward. So once again, thank you for the presenters, and thank you for attending. And we will, again, just as a reminder, we will have QCell staff in the questions platform for a little bit. But for now, thank everybody for attending today, and we look forward to seeing you in another webinar very soon. So thank you.
Thank you.
Thank you. Bye.
Thank you. Bye-bye.
Bye-bye, everyone. Bye-bye, everyone. This webinar is now closed. Thank you.